Hello everyone and welcome to the next webinar series. This is Aparna Deshmukh, Technical Director with Next, and I will be your moderator for today's session. So we are excited to dive into today's webinar titled GFRP Wire Mesh as Internal Reinforcement for Slab on Ground and Non-Structural Applications, Specifications, Advantages and Case Studies. A PDF of this presentation can be found in the handout box. You can use the PDF to follow the presentation and take notes if you desire. You may also use the question box to ask questions during the webinar, and our speaker will be happy to answer them at the end of the presentation. For continuing education credit, attendance for the entire duration of the webinar will earn you a certificate of completion of 1 PDH. Your certificate will be available in the ACI University under the Certificates tab within 2 days. For those who cannot join us live, the on-demand recording will be made available about a week after the live presentation. ACI is an approved education provider for American Institute of Architects and the International Code Council, and this webinar has been approved for one learning unit. So let's look at the description for our today's webinar. This presentation will explore fiber FRP mesh solutions for concrete reinforcement aimed at professionals interested in innovative materials. It covers a variety of FRP mesh options, their applications and benefits such as durability and workability in non-structural reinforcement and rehabilitation projects. Through case studies, it provides insights into specifying, designing and applying FRP meshes, making it valuable for both FRP experts and those new to the field. The learning objectives for this webinar are as on the screen. So let me introduce our today's speaker. We have Dr. Francisco Di Caso. He is the principal scientist at University of Miami. We have Mr. Igor Letinov. He is the business development manager at Benevier Composites. And we have Dr. Alvaro Ruiz Esperanza. He is the postdoctoral associate at University of Miami. So with this, I'll hand it over to Igor.
Aparna, thank you so very much for your introduction. Hello, everyone. Welcome to our webinar. Today, we're going to be talking about FRP meshes, specifically GFRP meshes used for slab on ground and non-structural reinforcement. So today, we will touch several topics. First, we will start with FRP. What is FRP? What is GFRP? What stands for FRP? Why do we use GFRP meshes? What's the case and what's the reason for so? Then we will definitely describe the specification of FRP wire mesh and then the real-world application and case studies. However, as with ACI, progress never stops. We will also touch the future development. So what is GFRP wire mesh? To discover that, let's discuss what is FRP, what stands for FRP. So FRP is fiber reinforced polymer. It means that we have fibers and polymers involved. When it comes to fibers, there are multiple variations, the same with the resins. So basically there are two main type of resins used to bind the fibers, either thermoset resins or thermoplastic resins. So when it comes to thermoset resin, there are several options as well. It can be vinyl ester resin, epoxy resin, polyester resin, polyurethane. When it comes to fibers, there's a great variety as well. It can be glass fibers, basalt fibers, carbon, and aramid, known as a Kevlar as well, but Kevlar is a trademark. So to figure out what is very easy. We love these acronyms in our industry, but it's pretty simple and straightforward. So for GFRP, it's a glass fiber reinforced polymer. So the first letter means the fiber type used. Same with the BFRP means basalt, CFRP means carbon, and AFRP means aramid. And here on the slide, you can see the difference in the appearance of different bars. Glass is obviously white, basalt is dark olive or brown, if you will, carbon is black, and this goldyish color is aramid. And the resin looks the same. Pretty much all resins look the same. Okay, to manufacture the FRP or GFRP specifically, wire mesh, we have to produce wire or the rebar first. So this slide you can see the production method called pultrusion described with the pictures and the scheme. So the first we have to take fibers itself from the krill, send them to the bath with the resin, impregnate with the resin, then send them through the die and form the shape of the wire or the rebar. Then it depends. Some bars or some wires are sand coated, or it can be some other surface treatment. Then bars or wires has to be heated to cure the resin. And in the end of the line, we have this pulling system and the cutting machine. So pretty much it's can be very well seen here on the slide. From left to right, all stages of the manufacturing process are shown. So when we come to the point of the difference, why do we talk about FRP as a different material? And I would like to yield the floor to Dr. De Casser to explain the difference in the behavior of FRP materials compared to steel.
Thank you, Igor. And shifting gears, I want to focus on three main things in this slide, and specifically discussing wire also versus bar. So on the left-hand side, you see a scanning electron microscope image of a cross-section of a wire and a bar. The little dots would represent each individual fiber filament, and the darker part would represent the resin, as Igor has mentioned, that is surrounded by it. So a key aspect of a bar versus a wire is obviously the overall size. And as you reduce that size from a bar to a wire, ensuring that, number one, you have adequate distribution of the fibers, and number two, adequate saturation around those fibers is going to be critical in order for that wire system, in order to be effective at transferring loads as it goes through the concrete into the reinforcement. On the right-hand side, we see what is a typical stress-strain curve, and we see three colors. Let's start with the bottom, red. That is your typical steel 60 KSI performance, right? So you have that, what engineers typically love, that plasticity or that plateau, that horizontal line that continues probably all the way until it's a very large deformation, right? This is a ductile material. It elongates. And we'll start here by saying that FRP does not behave like that. And by knowing this behavior, we can design accordingly. When we compare steel, the red line, with its next door neighbor, the carbon CFRP, that would be the blue line, we see the main difference is that this is a linear elastic material. So it's one line from loading to failure. Number two, we see that the slope of the CFRP is very similar to the slope of the linear elastic portion of steel, which means that the modulus of elasticity, which is a measure of the stiffness of carbon and steel, is very similar. And for that reason, carbon has specific applications for pre-stressing. Switching to the last curve that we want to focus on is representative of a glass fiber reinforced polymer element. We will notice three things, right? Number one is the slope. Compared both to the blue and the linear elastic portion of steel is significantly less, about a third or a quarter of that off. And again, this is an attribute. This is well established. We know that the stiffness of glass FRP is what it is, and we design accordingly. Even though it has a reduced stiffness, when we think about wire reinforcement, one significant advantage is that deformation of that structural element, that slab on grade, and case studies that we will see, does not typically govern the design. So for that reason, wire FRP has a specific advantage on this type of flat work, because stiffness does not play a critical role. Number two, we also see the linear elastic, right, is linear elastic to failure. And we will see that in the y-axis, right, the vertical axis, it is 2 times or 3 times the strength of steel. So it can certainly carry more load as we look on the y-axis. And last but not least would be the strain limit, or in the x-axis, which we don't really see over here, but typically for glass it could be as little as 2%, so the dot would be at 2%, or it might extend all the way to 3% depending on the GFRP. And there would be failure there. So the strain limit, or the deformation of GFRP, is significantly less to steel. And it's important to say we have a good and fundamental understanding of these materials, and with this understanding we can therefore understand how to design and how to use them. And obviously I went a little too far, so let me go back. And I should open a parenthesis that currently as chair of ASTM D3010 subcommittee on composites for civil structures, we're working on an FRP mesh specification. This is a standard specification, and this specification is looking at the classification of different FRP mesh types. And we're primarily dividing this in 2 parts. On the left-hand side, you see what we call the wire type, right? So these are typically going to be composed of longitudinal elements that are less than 1/4 of an inch nominal diameter. And you can see the designations W1.4 or 10 gauge. So we are borrowing the same nomenclature that steel has in order to adopt and classify and identify the different dimensions of these wires. And in the same way, you have on the right-hand side the Bayer type mesh or mat. And these are typically formed starting from number 2 bars, or 1/4 inch nominal diameter bars, and then assembled together in that orthogonal X and Y direction in order to do them. The main things is that they're going to have typically a bidirectional approach, intersecting at orthogonal angles, and as well they're going to have a spacing. And it's important to understand that the spacing doesn't have to be equivalent in both directions, and that will be depending on the application that you have, if you want to have more reinforcement in one direction. And as we will see, and as Igor introduced on the manufacturing, there can be different spacings between both the primary and the secondary direction. Talking about the mechanical fastening, or how do we tie those elements either from a wire standpoint or from a bar standpoint, I think the industry is experiencing a lot of innovation and a lot of creativity. And I think on the left-hand side, you can see what is typically seen, and this is an example for bars, where plastic zip ties are used. Should open a parenthesis that steel or coated steel ties can also be used on this type of applications, although it is typically not preferred in order not to introduce any steel in the concrete section. And on the right-hand side is a photo that Igor took at the last World of Concrete as a startup company. And what you see on the top are those 4 FRP bars that are running longitudinally. And this is a manual operated machine that can put ties, in this case 4 snap ties, at each instance when you press the button of this prototype machine. So then you can slide the bars however much you want in and out of the photo, and then place the other bar, and then snap 4 ties. So this gives you an idea that if you're looking at manufacturing either offsite or bringing the fast tying and reducing labor of the tying, in this case this would be applicable to the bar type meshes. There are certainly a lot of solutions, from the traditional manual ones to a lot of more innovation. Another type of connection is injection thermoplastics, where it creates a plastic weld, in essence, between those elements, in this case the bar elements, controlling both the spacing and the location of each of the bars. And that's primarily the objective of that connection, or that quote-unquote weld, is to ensure that when handled, when placed, and when casting, they stay in place. So we do not want to see any displacement or any relative slip between those mesh elements, let that be a bar or a wire type. so that even if you handle it, you take it out of a truck, you throw it, you step on it, as we will see on some videos, the joint becomes very important in making sure that the mesh remains integral to its dimension as it goes through the construction process. And on the right hand side, you see an exciting photo, I think, at least I find it exciting, on coiling, right? So when we start talking about small diameter bars or wires, you can certainly start coiling the material, which hopefully makes you think transportation, hopefully makes you think different locations for obtaining the mesh, and then manufacturing meshes near the construction site by having larger quantity of volume being shipped without shipping too much air. So exciting stuff happening around the wire site. And the last example I wanted to share in terms of connection, this is also another type of chemical weld, where in this case, on the left-hand side, you see that the wire element is being weaved through the mesh. And since it's being weaved as the fiber is getting saturated and protruded in that machine, then the resin will cure, harden, and creates that basically a chemical weld holding both elements in that direction. And on the right-hand side, you see what is a representative pultrusion wire mesh machine. So in this case, on the left upper side of the picture, you see what the bath and the resin and the saturation is, and closer to the front of the photo, you see how the machine is bringing out actually is the other way around, is the dry fibers that are inserting over here, and you can see the weave element as it goes through through the chemical bath and the curing. So in this case, it's a sort of like a one-step approach where the mesh is being produced simultaneously without having to do post handling of connecting those elements. And with that being said, hopefully, if you're thinking about why we should a wire mesh, if you're not 100% sure, Igor is going to clarify that for us. Igor?
Thank you, Francisco. So do I have a control? So why use GFRP wire mesh? I got a few brilliant examples. I like these pictures because it definitely shows the difference between steel wire meshes and FRP wire mesh and its appearance. And both can be kept outside, and unlike steel wire mesh, the FRP just doesn't rust. And that's a brilliant property that we're going to be utilizing. So, however, there are several key attributes to any kind of FRP meshes. They're relatively fair to all of them. So first is the durability. As this is non-metallic material, it is absolutely corrosion free. Then we have a weight reduction. In some applications, it is really very critical. The productivity and speed of construction, that is just a game changer. When it comes to the workability and the speed, it's crucial. That's loved by contractors. The absence of memory, or vice versa, we can say that it has memory, stays flat all the time. Higher tensile strength, as Dr. DeCasso emphasized before. Yep, we have and we understand the mechanic very well. The FRP as a material is stronger in terms of tensile strength, and we know exactly how to address this in the design. Then the sustainability and the lower carbon footprint, and that's pretty tricky stuff because FRP itself has a lower carbon footprint compared to steel reinforcement, has been proven. However, in many cases, the use of FRP reinforcement may allow us to reduce the amount of concrete used in the project, and then brings an additional savings on carbon foot impact. Electrically and thermally non-conductive. That is one of the key properties of FRP materials. In some areas, we do use this property, like MRI rooms where we do not need any magnetic interference, or FRP material is used in wall ties or sandwich wall application where thermal conductivity or absence of the thermal conductivity is actively used. But talking about some real key aspects is the lightweight of the mesh. So just to compare the typical roll of a standard roll of steel mesh, 5 feet by 100 feet, the weight of the roll is going to be over 150 pounds. I would not be able to lift it. However, when it comes to the fiberglass wire mesh with exactly the same dimensions, 5 by 150, it can be easily lifted by just one hand. And talking more about workability on the job site, we have 3 videos that we would like to share with you and show you the real-life examples of the workability advantages. Aparna, would you please run the videos for us? I got this video from the UK maybe a week ago or so. It is a topping screed or topping layer of concrete on the existing slab, and mesh on the rolls itself. It lays perfectly flat, so there's no memory, as we said before.
I should say, have you seen how the workers are looking at the mesh as it unrolls? If we can play that again, I think that's
it was the
just
first
as
time
impressive as the roll been coming through. Anyway, sorry to interrupt.
Okay. There we got the same video, but
look at the faces of the work. I think this is fantastic. Look at the guy. He's like, is this really happening? I think that speaks volumes. Sorry.
I would imagine how much time and labor were saved there. Yeah, this video is courtesy of Saudi Aramco team. So it clearly shows there is really no memory. We can step over the mesh, drive over the mesh, it will stay in place. And the third video, yeah, love that one. The cutting process, it's very simple. Brilliant.
I think as we wait for that on this slide, specification is very critical. Right? We understand that if you're at any part of the value chain of the construction, if the products are not specified, number one, you're not going to have the assurance of the performance of the product. Number two, the owner or client or whoever they're not going to be able to communicate clearly what is it that they need. So specifications really establish this relationship between a supplier, an application, and a client or a buyer in order to provide that. Alvaro? Well, I'm going to go ahead and keep going on the next slide if you want, and I'll steal a little bit of Alvaro's thunder. Okay, so in terms of specification and qualification, and I should acknowledge that Dr. Ruiz is certainly leading a lot of the work in the American Concrete Institute 440 Committee H, and translating a lot of the innovation that we have as we are going into its application. And when we look at a specification, we're primarily looking at testing and evaluating the product. Testing both parts, the product as a resultant overall product, so that's the mesh that you see on the bottom, but it's very important also to evaluate and test its constituent materials. And by doing that, for instance, by understanding the fiber type, we can then reference fiber specifications that as long as you use a specified fiber, you know that the mesh that you're fabricating will allow to meet certain performance. So performance-based specifications become very critical at advancing the industry. And to that extent, and as I mentioned earlier before, there is currently a working item in the ASTM in order to develop a specification for mesh FRP systems. And in part, this has been as a resultant effort of Nex's work and investment through research on a prior work. So, but we have to finish. The mesh itself has both physical and mechanical properties. Those physical and mechanical properties that you see in the screen will vary. And these are very driven based on the performance of the material in its location, in other words, in concrete. And it is important that all of these requirements are evaluated and measured to assure the performance of that product. If you don't have them, if you're missing one, if you're nearly there, it's sort of like, well, you didn't quite finish the race. The finish line was a meter in front of me. It doesn't mean that you finished the race. And that is important because some products might not fully qualify some of these aspects. And therefore, those shortcomings with a specification assure that the system that you have is meeting the requirements. And to that extent, already the International Code Council evaluation has an acceptance criteria, 521, that goes through the entire requirements of qualification testing to qualify that product, in this case an FRP mesh, for its application in the building environment. I'm not going to go through all the different ASTM standards, but the arrows that I'm pointing out are sort of the differences, primary differences compared to other FRP rebar products. So these are additional tests that are specific to the mesh type of reinforcement and its application. And as a side example, this is what we call an evaluation service report. An evaluation service report is issued by the International Code Council. And the evaluation service report is a way to show compliance with the international building code requirements, as you can see on section 1 of the scope, and how the design and the installation and the conditions of use. So this provides the engineer of record in any project, as well as the owner, an assurance that that FRP mesh meets the criteria for its use in a building environment. And that way accelerates the process of implementation so that we don't have to reinvent the wheel from a qualification point. And it is very important that with this type of validation system, you know what you're getting and you know it has met and underwent all the different things. And this is a great example coming from Vinivir of what a manufacturer that has completed this exhaustive process, that I should add is not, and maybe I go back, I'm not sure if it appears, but if you look at the remaining sections of an evaluation service report, like section 6 and 7, it will make reference to a very important aspect of the entire product, which is the quality, the control, and the assurance. Right? Not only the physical testing and mechanical testing as we just discussed, but in order to be building code compliant and that mesh product that you've tested and evaluated is the same product that you will continue to produce and sell, in order to meet that assurance, the ICCS provides requirements for quality control documentation that a manufacturer, like the example that we see on the screen, has to meet. And the manufacturer will consolidate, in a sense, the information coming from an evaluation service report. In a left-hand side, you might have a concise table that provides you with the specific material properties that you will need in order to design for it. And then on the right-hand side, manufacturers might provide the design professional sort of easy to look up tables that are specific for the product in order to understand the spacing, the thickness of a slab, and the different design parameters in order to easily implement that product, that FRP product, into a project. Therefore, expediting and facilitating the entire design process so that you could easily pivot from a traditional steel reinforced horizontal slab on grade construction into a non-metallic FRP mesh, taking advantage of all the benefits that have been previously explained. And as we go to other current specifications that exist, I finished with this slide before passing it over to some projects, is ASTM D79 and 57, as well as D8505. These two ASTM standards primarily talk about FRP rebar. They do start on a number 2 bar, and you will see that manufacturers will provide mesh products using those bar products. So therefore, you can get already specifications on the bar that meet those criteria, and then, in a sense, reassemble them in order to produce a mesh. So in lieu of a mesh-specific spec, you can use the current rebar alone specs. Additionally, ACI 441R, which, as I mentioned before, Dr. Ruiz is currently co-chair of the H subcommittee. They're leading an update of that document that was last published in 2015 in order to bring a lot of the innovation that has happened basically in the last nearly 15 years in order to be up to speed on the work that has been done. 440.3, 440.7, and 440.9 are also additional documents in terms of construction, specification, testing that can help throughout this process, where if there's a gap addressed that maybe a professional designer or engineer of record or somebody in the value chain of the construction identifies, many of these gaps are typically addressed on the specifications reference. When we look at our neighbors on the north, Canadian Standard Association, CSA, also has developed specifications that are robust. And when we look across the Atlantic to our European allies, the ISO has the 10406-1, this specification that contains all the testing related to FRP bar and mesh product requirements. And I should say that many of those test standards in the ISO are very similar to the ASTM standards referenced in the other ASTM specs. So all in all, there's sufficient know-how and volume collected in the specifications in order to support the industry and the implementation of these FRP mesh products. And with that being said, I'm going to pass it over to Igor. I'm going to stay connected while we go through some exciting case studies. And before we start, I'd say, you won't be the first doing it. So you can get that off your chest. Nobody wants to be the first on a project implementing something new. So that's very important. And there's a lot of information out there to learn from what has been done. So the reality is that not only you won't be the first, but probably it's not the first time that is being done either. So with that being said, Igor, if you want, I can click while we go through it.
Oh, thank you. Yeah. Coming to the real world application, we have 3 different general applications like repair and strengthening. That's one. The new construction, primarily slab on ground, of course, and some specialty application. Here in the right-hand picture, we can see the mold, and that's an on-site precast project. However, it's pretty easy to work with this type of meshes on a job site or inside the precast factory, or like here there was a combination. So next please. Okay, as Dr. De Casa mentioned, our alliance from Europe. So this bridge was repaired and located in Prague, Czech Republic. That's pictures of courtesy of Orlitech, distributor of materials in European Union. So the existing concrete structure was repaired, and this topping layer of in this case it was stucco, was reinforced with FRP, and there was no metal inclusions, including the anchors to connect existing concrete structure to the wire mesh. They were also made with the FRP material, so that's completely non-metallic topping reinforcement. Next, please.
Let me talk a little bit about this one. I think it's very exciting because it talks about, number one, the malleability of the product, right? Being able that is lightweight and fitting it into close quarters. And these are pictures coming from an inside drain reconstruction. These are typically short, I wouldn't call even bridges, but just bypasses that are going through a road, typically on very difficult to access areas such as forestry and woods. But these drain reconstructions are critical in order to ensure proper drainage during rain periods so that the roads that are typically located under do not get damaged through the erosion. And it's a very difficult to reach area, difficult to reach locations. And here we're leveraging both the flexibility of shotcrete application through the nozzles and the lightweight material being able to insert in and go through the process. And then on the right-hand side, you have bigger diameter pipes that, again, it's a matter of being able to mold that system. And I think this is typically a misconception for FRP materials that cannot be, I'm going to say bent, but a better word is curved to shape an existing construction. So they can be certainly curved to mimic the shape of an existing surface. I would say that bending them, that is clearly not feasible from a 90-degree angle. But as we saw also from the coiling approach, you can certainly have relatively short radii, especially for the smaller diameter wires, without causing any strain, loading, or damage to them. Igor?
Yeah, but I would get back to the previous slide, because what I love there is talking about different attributes of FRP bars. We mentioned the durability. As the material is not prone to rust, it's just a perfect application. But the next slide, we have the same win. So I was honored to see this building in the drawings back in 2015, I believe, or 2016 or so. And then we got a challenge from the engineering team for the project if we can substitute the steel wire mesh with something that non-corrosive. And we came up with it was just when we started developing the mesh product as a final product. So the same shotcrete application, the type of construction, and then another honor that I had is to visit this amazing building or structure as a tourist, and I had a chance to take these pictures. So it's still there, have no signs of rust, and I'm happy we accomplished it. And again, the ties or anchors were non-metallic, so we do not anticipate any bleedings on the walls.
Very good point. So not only the mesh itself, but the compatibility of holding that mesh into place with non-metallic connectors. I think more of a not so attractive type of project, but certainly very critical, is pavements and slab on grounds, right? These are critical for our infrastructure. And in this case, this is over at a Marathon International Airport down south here in South Florida. Next to the coast, in a very high salinity environment. It's in the air. It's everywhere where you go, and very straightforward. You can see the limited amount of work, and I think parts of these were cast on top of the existing pavement before, right?
Correct.
No major changes into the work. I think one of the main aspects of this type of work that we see in the photo is that the contractor delivering the concrete didn't need to change anything. And then number two, we see that because of those long rolls that we see into the page on the left picture with the truck, the amount of waste that you have because of the splicing or the overlap that you typically need in 8 by 4 foot wire meshes or even rolls is significantly limited. By ensuring that you have that long length, you're limiting the number of splice, so you're also reducing significantly the amount of waste and material that would otherwise not be used. So lessons learned on that. Next slide, Igor.
Yeah, welcome to Australia. So yeah, that's still ongoing project for many years. The on-site precast seawall sections later installed as an actual seawall. So the interesting part here that the mesh is made of two different rebar sizes. It is number 4 bar or half-inch bar in the longitudinal direction, and a 10 millimeter or number 3 bar in the perpendicular direction. So, and the joint is made with the thermoplastics, and if you will notice that the left and the very right rebars have slightly different spacing, so they are closer to each other than the bars in the middle. So this is what the flexibility of the mesh manufacturing process gave us this advantage. But other than that, the two main aspects were critical for this application. It's first the non-corrosive properties of the FRP wire mesh, and then just the workability aspect. As the mesh was pre-made, it was very easy to be laid in the mold, and just the weight of FRP itself was was critical there.
And again, I think I reiterate that the ability to customize your mesh reinforcement is very critical. This doesn't really happen when we look at the state of the art in steel, unless you're using just rebars and handling them, and then through labor manually putting them. This quick other example, also in the precast industry, looking at sandwich panels, right? Sandwich panels where we want to reduce the thickness of those elements. We want to reduce the weight of those elements. And this is another core application where, again, you know, the serviceability type of requirements that these panels have, many times they're non-load bearing or they might be minimal, is a great application for materials where the stiffness of the reinforcement is not comparable to that of steel. So excellent example, easy handling in the precaster, no changes to the precast process and construction. And you can see in this case, they're using those circular things as the ties. Igor, what are those?
The spacers.
The spacers, yeah. So they're using I mean, they're sort of randomly thrown. It seems like they grabbed them and they threw them. So interesting way to spacer. And again, I think it just creates that approach whereby the impact on existing processes of construction is significantly minimized or uninterrupted. Igor?
Yeah, the topping slab. This is exactly the same project where we took the video before. So you can see the wires or the wire mesh was supplied in the form of rolls that technically and basically unrolls itself and lays absolutely flat. So this topping slab, the reinforcement was installed in 2 hours compared to 6 to 8 hours if that would be the steel mesh reinforcement. That's the data that we got from the contracting company. Okay, yeah, that's another case study from the UK. It's Devon County, England. It wasn't that easy to access this construction site because it's quite steep steep slopes there. So the workability and the lightweight of the material was critical there. However, the durability was an extremely important aspect as well because we see the seawater everywhere. It's a high chloride environment, and the shotcreting as a construction method was used there.
And in adding to that, I guess I think a misconception that I hear from many colleagues is that sometimes the shotcrete power, right, or the projectile of the shotcrete, it is believed that it might damage this, glass type of systems. And this is again a misconception that can be that the shotcrete process can be calibrated in order not to damage any of the reinforcement that is used. And actually, it is used as a quick example on sandwich construction where you're projecting onto the polystyrene and that doesn't get damaged. So it's important to understand that obviously it's not just any shotcrete application that you're using and that you have to be cognition of the process that you're using. But it is compatible and can be compatible. As for example, in this other specialty project, this is a skate park located underneath Interstate 95 in the middle of Miami, where that area was reutilized, and you can see the surface finish on the right-hand side. I should say that skateboarders have very high specification requirements on the finish and the hardness of the concrete to skateboard. I was pretty impressed about how much they actually know about concrete. And on the left-hand side, actually, they were a little hesitant, in this case, using this basalt FRP mesh. So a demo section was done before and finished, and that's halfway through the middle of the shotcrete process that was being used. And at the end of the day, they were happy. They were happy with it. So I think this gives an example that if you're adopting something that is new to your industry or new to the stakeholders in that area, you could always start with a smaller project, look at a little demo, and then move it from there. Another quick case study over here are driveways, right? Again, slap-on grades. This is a driveway on a residential construction over in Boynton Beach, again, Florida. A lot of Florida examples where, I don't think durability or corrosion resistance was the driving aspect in this, but more about the workers being able to have both productivity, but also to reduce the fatigue and just the work related to placing steel, reinforcement of it. And similarly, this last example that we finished with is on pedestrian walkways. Let's go on to the next one. So, any type of sidewalks or pedestrian walkways, typically 4-inch thickness, minimal reinforcement to keep them in place and avoid any cracking and whatnot. So this is another great application where we can even leverage the properties of the concrete in order to bring down the cost of the entire project, whereby we might not need now to look at admixtures or other elements that we put into the concrete mix in order to passivate the steel and protect it against corrosion, but instead we can just go ahead and use non-metallics and modify a concrete mix to a standard concrete mix that's just no non-metallics, and that drives down the overall cost of the project, as concrete ultimately is most of the materials. Shifting gears onto future work, Igor, do you want to tackle this slide and I'll do the next one?
I like actually Alvaro to take care of these slides because he is the most critical part of the puzzle here.
Okay, so what's next? I think Francisco well mentioned about the development of the new ASTM standard, which is in ballot. It's of great importance to have standards for the safe and efficient use of this type of materials. So that's why within ASTM D30 we've developed, Dr. De Caso actually was leading those efforts of developing the new ASTM for FRP measures. So tailor characterization. So to propose a more detailed characterization methods, we've heard that there are some standards that help design with FRP measures. I think we can do better. Next, it's actually helping us a lot to the entire industry to put these tailored characterization methods and design methods together, which that ties into the next point. One thing is to have specifications and characterization of the material. Then the next step is, okay, now that we know how the material behaves, how can we design it properly and efficiently? And not only that, also a lot of the times, as Igor and Dr. De Caso mentioned, a lot of these applications are slabs on grade, are not very skilled in a sense, engineering-wise applications. So having design tools that are simple in a way, but that incorporate the required characterization and design guidelines would speed up a lot the use of FRP meshes throughout the entire construction industry. And finally, to educate the market, I mean, this is critical whenever you talk about new, in a sense, construction materials, even though we've heard that this has been out there for a while, but there's still a lot of people that they don't know about FRP meshes, their properties and advantages and how to use them. So educating the market, it's critical, doing webinars as this one, and doing a lot of lunch and learns and conferences so that people are aware about this other tool in the toolbox that we have in the construction industry. So getting a little bit deeper into the ASTM standard, as I mentioned, here you have the ballot document that was posted for ballot, which includes the standard specification for fiber reinforced polymer meshes for concrete reinforcement. We should be getting the responses soon. As you all know, this is an open process, so everyone can vote within the committee and outside too. So, I mean, if you have any additions, please feel free. I think we're running a little bit out of time, so Igor, if you want to go to the next slide.
I think
okay.
Yes, please. If you have any questions, concerns, please share.
Thank you so much, Alvaro, Francisco, and Igor for your presentation. It was a very insightful and the insightful case studies. I'm confident that our participants enjoyed your presentation and your insightful case studies. So going with the first question, can this mesh be used in precast modular building members like wall?
The answer is absolutely. I think we had those examples, and typically the barrier would be the company or the precaster, since there's the first time they're using, is a little hesitance. And I'd say, just ask them to not change anything, don't change your molds, don't change any of the process, just change the reinforcement, let's go through it. And you'll be surprised how welcoming they are after sort of breaking the ice. But the short answer is yes. Again, depending on your demands and your capacity of that modular panel, if the load bearing or non-load bearing, the amount of reinforcement and the spacing is going to need to be verified. But in terms of adopting it, that's not an issue now.
Great. Thank you. Our next question is, what is the price compared to steel wire mesh?
It's very similar. If we will just compare the W1.4 mesh, the retail price that you will get for the mesh made of steel and FRP going to be equal. However, the workability and the lightweight of the product is a benefit to contractor.
Great, thank you.
Right. I would, if I can add to that, I would caution the individual that questioned that, looking at the material property is one thing, and obviously depending on where you are in that chain, that value chain of the project, really try to think of the entire project itself. And as I mentioned in the last set of examples, if you are able to adjust the concrete mix, you might be significantly reducing the cost of the overall project by adopting a non-metallic reinforcement, as it allows you to really rethink the mix. So even though the reinforcement might be equal or maybe more expensive depending on the volume, on the size of the project and whatnot, ultimately, if you can consider labor, time, and concrete, it certainly, and that's not including maintenance and long-term.
We're not even touching. Yes, we're not even touching
Right.
the topic of life.
Again, if you're the contractor, you don't really care about that. But anyway, that's a good question.
Yeah, so it also depends on life cycle cost, right?
Yeah. Exactly.
So our next question is, when you say FRP is sustainable and lower CO2 footprint, do you have any percentage quantification as compared to steel?
I would encourage the person that's asked this question to join us at ACI convention next week, where we will be talking more about carbon footprint and sustainability during our workshop. But yes, there are several examples of significant carbon footprint reduction achieved by the use of reinforcement and by reinforcement itself, because the carbon footprint of wire mesh or FRP reinforcement is lower compared to steel just itself. However, understanding the non-corrosive properties of FRP materials, if we design properly, the significant savings in the amount of concrete can be achieved, and that together with the savings on reinforcement will bring to a significant reduction of carbon footprint and impact.
Great, thank you. Our next question is, are there any guidelines which will help new designers to study or learn the design process for all the case studies shown in the presentation? Yeah.
I can take this one if you guys want. So yes, as I briefly mentioned, there are guidelines. So ACI, the American Concrete Institute, has the ACI code, which is actually the 440.11, which is actually for bars. But as you guys have seen, a lot of the meshes are made of bars. So eventually you can use that ACI 440 code. So that's one document. There's another one, the PRC 440.1R. The one that Dr. De Casio also mentioned at some stage of the presentation, which is a guide. It's not a code. but includes a section that is specifically for slabs on grade. This guide is being revised within the 440H committee, so it will be updated, incorporating other type of fibers and other type of applications. And then there is also, there are other guides and codes specific for certain applications. You have the ASHTO code, which is, again, it's technically for bars, but a lot of those bars are made, a lot of the meshes are made of bars. So, you can use those.
Great. Thank you, Alvaro. Our next question is, can the thermoplastic joint sustain the handling stress?
Oh yeah, absolutely. Absolutely. One of the QC tests that we have as a manufacturer is the drop test. So we drop it's Francisco, no kidding there. We drop the roll of the mesh from somewhere about 5 foot and see how it performs. But basically, yes, of course, it does. That's the main purpose of this plastic joint.
And in addition, from a specification point of view, similar to welded wire mesh, there's a test of the joint in order to develop the magnitude of that capacity. So I think both from a specification point of view, and there's many ways to do it, right? SIP ties, for instance, you probably need to put 2, depending on the bar of the size and depending on if you're doing it on site or the handling. But that's a great question, that it is important that it's not only the placement of the concrete, but also the handling aspect of that joint. If you're getting a pre-manufactured mesh, handles all that demand.
Noticed if for whatever reason in this W1.4 specifically mesh, if one of the joints is broken, as the wire itself has no memory, it stays in place. So several joints rather hold it.
Great, thank you. Our next question, what are the safety concerns, if any, associated with GFRP, that is dust control, while cutting or installing?
It's a great question.
I'll take that if you want. I think in a similar way of the safety concerns that you might have in a construction site in terms of wearing your personal protective equipment, there would be nothing that differs from that, right? Obviously lacerations, handling and whatnot, that the same that you would do with steel. So there's nothing really significantly different from even though it's a plastic or from a chemistry point of view or whatnot. This is already a cured material, so there's no volatile based compounds that would affect. So there's really nothing different to what you already have from a safety point of view for use in general construction. Great question.
Okay, thank you. And we have one more question. Following up on the precast application, is FRP covered, permissible within PCI handbooks, design manuals, and or ACI 318, or is this part of what's next section?
Dr. Ruiz, you want to take this?
Yeah, so if I understood correctly, the question was related to the cover, right?
No, is it on the PCI
no.
handbook and 318?
Yeah.
And then PCA was involved as well.
So PCI handbook and 318 does not include FRP right now, right? But we have the ACI 440 that was mentioned before, which is the equivalent of 318, but for FRP. Actually, it follows the same structure. It has the same section, so it's very easy to follow for those that are used to 318. Whatever it's on chapter 3, it's on chapter 3 for 440 for FRP. So it's the equivalent for FRP, but it's not included in 318.
Yeah, we have 2 more questions. The one is, can GFRP waste be recycled?
That's a great question. And I think when we look at the wind industry and the wind turbines, right, this is a great sector that it's plus 30 years in the making, and they are experiencing that the downgrading of the wind blades and whatnot, and what they're doing, and there are many ways around it. I think there's many solutions being done today. I think when we look at a reinforcement in concrete and separating the FRP is one question that doesn't need to be separated, number one. My answer from the work that has been done so far, it's not. That concrete will be crushed, and the entire reinforced concrete element will be crushed, and that crush used as recycled concrete aggregate. And therefore, the rebar or the mesh that is within that bulk product, then recycled as needed. And that also opens the opportunity that today we can use recycled concrete aggregate that typically has a high pH level. It is a contaminated product with non-metallic FRP reinforcement and mesh. And it doesn't matter that the chlorides will be higher, right? And that the pH of this concrete will be more neutral, right? So why? Because we don't have metal, so we do not need to passivate or protect the steel because there's no steel. So I think the short answer for that in the current term is that you crush it all together, you recycle that concrete, and you reuse it in either non-structural or structural applications with a non-metallic reinforcement. But there's certainly a lot more to that question than the answer that I have in the few seconds that I'm providing.
Okay, thank you. Thank you so much. And our last question is, how about fire resistance of GFRP materials?
In general, Francisco, will you pick it?
Sure. So great question. And currently the 440 committee, also in the 440.11, which is the code. So 318 is only for steel and 440.11 is only for FRP rebar reinforced concrete. They're looking at this. There's a lot of work, and it's all about the detailing when it comes to FRP, meaning that the continuation of the reinforcement and the overlap is provided. There's certainly cover and issues that need to be resolved, but this is for structural elements, right? If we bring the conversation back to the wire and the wire reinforcement, fire resistant for slab on grade is not required, right? So the fire resistant for the skate park that we saw, not required. We look at sandwich construction. If that sandwich construction element is a non-load bearing and it's just a separation in a building, again, fire resistant is not critical. So I think this is a gap, and you will be limited based on your fire requirements for that application. And it's a matter of, if there's a requirement, maybe I don't want to have any headaches, we'll skip on this project for FRP. But if fire is not a requirement, then FRP can certainly be used. But there's a lot of work currently being in order to solve this design issues and address them, which are very present and are a limiting factor when it comes to structural approach of the design elements.
Yeah, Next also has a state-of-art report for FRP bars, which is free to download on Next website. So if you're interested, you can visit Next website, or you can shoot me an email and I can share you the link. With this, I thank you all for the wonderful question answer session as well. I have few announcements before we go. So Igor already mentioned, so we have a workshop coming up at ACI convention. If you are going to attend ACI convention, please register to for this workshop. It is next new workshop, Building the Future with Non-Metallic Materials and Low Carbon Concrete for Eco-Friendly Construction. The detail, it will be like in part 1 and 2, morning session 9 a.m. to 12 and afternoon session from 2 to 5 p.m. The details of this presentation and all the presenters are listed on ACI website, ACI events, convention events. So if you have any questions, you can always email me. Otherwise, you can refer to the website. With this, thank you all, the participant for this, and see you next time. Thank you. Bye-bye.